This is Neeraj Shukla here, your host and host, your mentor. And today we are going to talk about the ISO 7547. Yes, you have heard it right. This is also one of the module in my mega course for oil and gas HVAC. Now you all must be wondering that why I have chosen this particular standard and what is so special about this standard that sir is talking about it and what is it all about. Yes, since I've selected this particular standard for this particular course, it has a very strong significance. And let me tell you, unless you understand this standard, you really cannot proceed with your HVAC design. Yes, you're right. And what is the standard all about? This standard talks about the HVAC system, that is heating, ventilation, air conditioning system design basis for the marine installations. When I say marine, it's all about the ships. I have already explained in my previous module the types of ships and what is a ship and what category it comes in. All categories are ships, whatever the ship may be, falls under this particular standard. ISO 7547. With any interview you go, you should keep this in your mind. ISO 7547. This is your Bible when you are designing any ship air conditioning. And when I say ship air conditioning, you know what I mean. Ship air conditioning is ship air conditioning. So we are going today provision of each and every provision of ISO 7547, what it means, how many air changes it recommends, what temperature it recommends, why it recommends, what are the other things need to be considered, what are the ventilation rate to be considered. We need to consider everything as per this 7547. Remember. So, but don't worry, I'm going to explain you each and every provision one by one. And one more thing, when you're going to do this case study, definitely this will help you. All the standard rates you need to mug up completely. So you know which value to be used where. For the offshore installation, oil and gas installation, you have another standard ISO 15138. That is for the fixed installations. As you know, these marine installations are applicable for the oil and gas also, where there are the ships which are the oil tankers or ships which are the FPSO, that is floating production and offloading vessels, that is FPSO vessels. So FPSO vessels also have an accommodation for that. This standard is applicable, and wherever there are fixed oil and gas platforms are there, where you have a technical building or you have LQ or both, in that place you have to apply ISO 15138, but that is we are going to cover in another module. That is going to be a mega module, but this module also you need to understand very patiently, and you need to analyze by yourself. You need to take a note of it, and notes will help you, to be honest. So be prepared with your notes. So when you apply it, you will understand where to apply and why not to apply. So with that, we are going to go to the next one. This particular slide, we are going to discuss about the HVAC calculation basis. To begin with, what it contains, what it not contains. So you should read it very carefully. Whatever is written here is very important. It in short defines the scope of this standard. You know, in which cases it is applicable, in which cases it is not applicable. So let's go one by one here. As this name suggests, the standard ISO 7547 is ships and marine technology, air conditioning and ventilation of accommodation spaces, design conditions and basis of calculation. Here you need to remember that when I say this applicable to the ships, first of all, this standard is not applicable for the offshore structure, this oil and gas structure. That is a separate standard which we are going to check afterwards in the next or subsequent models. But when we talk about this standard, this is applicable to the ships, and not only to the ships, the accommodation part of the ship where people are going to stay. The captain is going to stay, the cabin crew is going to stay. Those particular accommodation which is on the ship, those people who are taking care of the ship, those people who are running the ship, those people, entire crew, what we say, which is on the ship, where they stay, that particular part, air conditioning only, this standard talks about. It specifies the design conditions and the calculation methods for various marine species. It talks about design conditions, the temperature to be considered in the room, all those things, that calculation, how to do the calculations, the U factor, how to calculate, all these things this particular standard talks about for the marine spaces, for the ships, that also for the accommodation part. Second, applicable except for the extremely hot or extremely cold climate as stated in various sections subsequent to this standard. When we say extremely hot or extremely cold, what does it mean? Extremely hot means anything more than 35 degrees Celsius ambient. This standard considers as an extremely hot. And anything less than minus 20 degrees Celsius, this standard considered as extremely cold. Then this is an ISO standard which is worldwide recognized. No other standard in marine industry or anywhere, even ASHRAE, defines the design conditions or calculation criteria for the marine species. So this is the only standard which we need to follow for calculation of the marine species for the ships. Then it talks about is limited to the specifying design basis for HVAC calculations for the marine sector. This means that the scope of standard, this particular standard, it doesn't go beyond the calculation methods. It doesn't talk about the safety and other issues and the health and safety and quality issue. No, it talks about only and only about the design calculation methods for the various marine species. So one should not get confused over here. Last is statutory and local requirement always prevails. It means that whatever the statutory requirement, if there suppose the ship is flagged for the Panama registration or whichever registration it has to follow, whatever the local regulations are there, those comes first and then the ISO comes later. But I'm sure no other local is specifying any stand over here. So this is just for the safety reason they have mentioned this statement. So in short, you need to follow the standard for the ships while we are designing for the air conditioning of the marine spaces of the ship. Clear? Let's move to the next one. This particular slide talks about the annexures to ISO 7547. This particular standard has several annexures, that is A, B, C, D, E, built in this particular standard. Earlier, each of the annexures was having its separate standard, but now they have combined it into the one standard they have mentioned it as an annexure. For example, annexure A, B, C talks about different aspects of the design. So let's take one by one what annexure A contains, and I'm going to cover it in the subsequent lectures itself. What is annexure A, B, C in detailed way. Annexure A talks about and provides guidance and details of good practices in design of ventilation and air conditioning systems in the ship. That I'm going to cover it. Then Annexure B, it covers and it gives a thermal conductivities of commonly used construction material in marine. Then Annexure C, it applies to the special consideration in machinery control rooms. Annexure D talks about document special requirement of the wheelhouse. Wheelhouse is a place where the captain is shipping and controlling the ships. So what is the HVAC requirement for that, and what are the considerations we need to do, that everything is covered in Annexure D. Then Annexure E talks about the special considerations for the dry provision stores. Dry provision store or dry provision rooms are the rooms where you are going to keep your dry foods, like pickles, and the places where you don't anything which doesn't need refrigeration. Normal air conditioning can work. Those are all the things, or wheat or something. Wheat, don't have to keep the wheat boxes mm, somewhere in the refrigeration. Nobody keeps. Or rice. So these are the places which are kept in the dry provision store. It's also very important. So the air conditioning requirement for that also is considered as a part of this particular annexure E. So this is what the annexure it covers, and we are going to see it one by one. Let's move to the next slide. These are the typical GA layouts of the marine structure. I'm going to definitely, it's only a rough to give an idea. And when we do this case study thing, then definitely you will have a broader idea in broader sense how it works. So this is just to give an idea that the rooms and how it looks and what does the cabin means, what does this mess room means, so what are the various areas it contains. So anyway, in subsequent lectures, I'm going to cover it, which are the major areas in the marine sector, so you will have some idea about it. The accommodation, it's very interesting one. So let's move on to the next slide in a short while. When we talk about the marine sector, there are certain terms which keep on repeating itself again and again and again. So we should know the definition of these particular terms, so understand it in a better way. So someone says, what is trap provision, what is wheelhouse and machine control room, so you all should be aware of it. What is accommodation? When we say accommodation in the building sector, the meaning is different. But when we talk about the marine sector, the accommodation means spaces used as a public room, cabins, office, hospital, cinema, games, hobby rooms, hairdressing salon, pantries, without cooking appliances. This is called an accommodation. Yes, in marine accommodations, these all things you may find. You may find a small cinema hall, you may find the games and hobby rooms over there, and offices and some small hospital. Hospital is not a big hospital, some small hospital, small, we call it the medic room. So small medic room you will find over there. So yeah, the life you may find it's very luxurious life and all, but you need to understand that kind of stress in which they have to live in the middle of the ocean. If you see nobody is there outside the window, only sea and no people, you cannot say. Sometimes you call it as sometimes it calls a depression. People may fall into the depression. So to move out the depression, they make these all facilities available to them. And you might be saying that food which is served at the marine guys, their 5-star food is there. If you see the lunch is there, it's a platter of lunch, everyday buffet is there. But you need to understand that the kind of food they are getting, the kind of the fruits or what they are getting, that is refrigerated fruits for more than 3 to 6 months, because ship has to sail in the sea, so that food has to be preserved. So that is not a fresh food what they are getting. It's a frozen food which get thawed and it is being served to them. So it's all about sacrifices they also make. So let's come to the next one. The machinery control room is a space containing the system of main alarm displays and controls for the proportional machinery. There is a proportional and thruster system by which rotates and ship moves forward or turns left, right, or whatever. So for these thrusters, we need some control panels or control systems, and electrical panels are kept in one particular room. That is nothing but a machinery control room. Wheelhouse is an enclosed area of bridge excluding radio cabin. That is this is a bridge, means at the topmost level is called as a bridge. So don't get confused with the normal bridge. Bridge is the topmost level of the marine structure. And last but not the least is the dry provision store. As I already explained in my previous slide, what is dry provision store? It's an enclosed compartment provided with lighting and ventilation for storage of provisions for ship's crew. That is dry provisions. It's not a wet provision, or it is not the refrigerated provision. It's a different topic altogether, refrigerated provision. So here you need to understand what is dry provision store, which I already explained. It's called as a pickle or rice or wheat. It is kept in this particular room. Okay. So let's move on to the next slide. In this particular slide, we are going to talk about the outdoor design conditions. Section 4.2 and section 4.3 of this standard define about the summer temperatures and humidities and winter temperatures for the ships. As you know that ship moves from one location to another location, we cannot take a particular temperature. But suppose ship is constantly moving only to the cold sector like marine and the North Sea, or suppose it has to operate in the Middle East only, then these conditions we cannot consider. But rest all other region, we can state this condition as mentioned in the ISO 7547. And if the ship is moving in the North Sea or the Gulf region, then we can take the respective temperatures of those regions and we can start the design based on that. So this section says like this: the summer temperature and humidities are as follows. The outdoor ambient condition for the summer plus 35 degrees and 70% RH you need to take. Then indoor room condition 27 degrees Celsius and 50% RH need to maintain. Then engine room condition, that is engines where the separate engine room is there where our engines are kept, and the one of the shaft goes to the propulsion and it moves the propulsion. So this is what very important aspect. And when we say 45 degrees Celsius and there is no control of relative humidity. Now the question may come that why 45 degrees Celsius when ambient is 35? How come 45? Because we need to mention that this 10-degree delta T may occur due to the heat dissipated by the engine itself. So this is what the 45 degrees Celsius comes from. So anyway, engine room will be hotter always than the subsequent rooms. And yes, in this particular course, I'm also going to teach you how to calculate the airflow for the engine rooms, these big engine rooms. So this is very interesting chapter that's going to be, because I'm going to show the calculation sheet properly one by one. Then I'm going to share you the soft copy also. So you can do by your own whenever you will be given opportunity to by your client to do the calculation, you are aware of it. So for winter temperatures, outdoor air conditions minus 20 degrees Celsius and indoor conditions plus 22 degrees Celsius you need to maintain. As I mentioned in the note earlier, all temperatures selected are the dry bulb temperatures, and because no wet bulb, because already if you see for the summer conditions 70% RH is there, and for the winter there is no relevance of relative humidity over here. All temperatures are stated as for the dry bulb temperatures. Above temperatures are not applicable for the extreme weather conditions. So this clearly defines it, and by this you might be understanding that heaters are eminent in this case. So we need to design the heaters accordingly, because you need to keep minus 20 degrees and plus 22 degrees Celsius. Of course, you need to have a heater. Or if you don't, if your client has given you the data, boss, this is what the data you have to use for ambient condition and winter condition, well and good. But if you don't have any data, this is what you need to take and start to design, because when any queries come, then you have your backup ready, that okay, on what basis you have calculated. Boss, I have calculated on basis of this particular standard, so you are safe, because I've already explained in my previous modules in this course that insurance is very important. Suppose something happens to ship and it gets drowned and all your documents get checked and they release insurance if all your design is perfect and approved and it has some basis. So you have a basis and your company is safe and your company doesn't have to buy any indemnity bond or any losses. You don't have company don't suffer. So tell these things to your boss also, that this is the importance of this standard. Now here the game begins from section this onwards. Outdoor airflow ventilation quantity. Yes. Now section 4.4 talks about the outdoor airflow. That is nothing but a minimum quantity of outdoor air shall not be less than 40% of the total air supplied to the space is concerned. That means whichever calculation you are doing to calculate the outdoor air requirement has to be minimum 40% of your total supply air. Okay, so this is an interesting uh, clause you need to consider while calculating the ship marine air conditioning system, and it has written as a shall not be less than. It is not written that may not be less than, may be, no, clearly stated shall not be less than 40%. So end of the story. Okay, so let's go to the next important section, section 6.2. There are other sections like section 4.3, 4.10, blah blah blah, but those are not relevant, or it is not explaining the things which is really you need to know. It's only nonsense theory. So focus on, I've selected only those sections which really matter for the calculation purpose. So next, move to the next section. That is section 6.2, supply airflow. The supply airflow to each air-conditioned space shall be calculated using whichever is the following criteria gives the highest value. Now let's see what ABC is. First is dehumidified supply airflow in summer, then dehumidified supply airflow in winter, and outdoor supply airflow not less than 0.008 meter cube per person, of which the space is designed. The air exhaust to the private sanitary rooms, bath, shower or WC shall be at least 10% higher than the air supply to the sanitary room. Now let's take what is 6.2 talks about. It talks about when you supply the air, it should be either dehumidified supply in the summer value, winter value, or each person wise. Always mention based on my experience, I am saying that value which is mentioned in first will be always highest, because in winter there is very less sensible load and plus less summer load, so this value cannot be higher in winter. And plus in outdoor air supply, maximum 100, if you take 0.8008 comes to around 30 cmh per person. So 30 cmh, even if you put 100, it becomes 3000 cmh at any given point of time. For such a big people on board and such installation needed, accommodation load will be always higher, and dehumidified same film in summer will be always higher. So without any worry, you can go for the criteria A over here. The second bullet point talks about the 10% higher airflow than the supply. The reason is that sanitary, the smell is there. So smell should not transform into the accommodation. So that it is saying that exhaust should be 10% higher than the supply. That makes sense because you are creating some kind of a negative pressure. So all the smell will go out from the exhaust. And the note is there for crowded areas such as the mess room and changing room, the outdoor air supply uh, should be, there's a value stated over here. That value we have to meet meter cube per person. And let's go to the next slide. In this particular chapter, we are going to talk about the air supply for the ventilation. Section 6.2 applies over here, that is air supply for the ventilation. It talks about the supply of conditioned air to the ventilated spaces such as those listed below shall be provided directly or by transfer of less vitiated air from an adjacent space, and shall be sufficient to permit the exhaust airflow required to be met. That means what it says that exhaust air to this particular areas can be taken from the adjacent spaces or by the exhaust fan, that is primary sanitary rooms. It includes bath, shower, urinal and WC, and laundry, changing rooms and cleaning lockers. In other words, it says that you don't have to directly take the air from this particular room, but whereas when you take out the room, the air transfer from the other rooms also you can consider. So this is what it all about talks. So let's go to the next session over here. This particular slide talks about the temperature of supply airflow. Let's go section 6.1. It talks about it's a volume of space. What it says as the volume of furniture, wardrobe, stationary equipment, etc. shall not be deducted in calculating the gross volume of cabins and other spaces. So as you know, when we calculate the ventilation air, there are certain air changes we need to consider. So when we need to consider the air changes, we need to calculate the volume of the room also. And when we calculate the volume of the room, there is always an argument that should we deduct the volume of the chair, should we deduct the volume of the furniture, should we deduct the volume of the bed and arrive at the airflow? No, it cannot be done. It is strictly mentioned in section 6.1 that you cannot deduct the volume of these stationary items. So you need to consider volume of a room as if it's an empty room. So section 6.3 here what talks about, it's the temperature of supply airflow. The temperature of air supplied to the space shall not be more than 10 degrees Celsius lower than the average temperature, nor the heating mode more than 15 degrees Celsius higher than the average temperature of the space. This means suppose your room condition or room temperature is 24 degrees Celsius or so let's say 27 degrees Celsius, then the difference between the supply air temperature should not be greater than 27 or 24 minus 10. Let us say an example of 24 degrees Celsius your indoor condition. So 24 minus 10 is equal to 14 degrees Celsius. So your supply temperature should not be more than 14 degrees Celsius. And suppose in the heating mode, it should not be more than, say example, 24 plus is 39 degrees Celsius. 24 plus 15. So this is what it talks about. So hope this section is clear. They have given what is the supply temperature should be in winter as well as summer conditions, and volume criteria also they have made it very very clear over here. This particular section talks about the exhaust airflow for the marine accommodation spaces. The section 6.4 talks about the exhaust airflow, and these are the various areas which are listed which forms the part of a marine accommodation. Say for there are rooms like, let's take a first one, that is saloon, mess room, dining room, common day rooms. Sorry. So the exhaust airflow from these rooms shall be same as supply airflow. And second one is your hospital, that is medic room, pantries and smoking rooms has to be at least 20% more than the supply airflow. The exhaust airflow should be 20% more than the supply airflow. And private sanitary rooms includes the bathroom, shower. The rate is 0.02 meter cube per second or minimum 10 air changes per hour, whichever is higher. Then fourth is common sanitary rooms. It includes common means it is not a private one. It's not for only two people. It's for many people. They are using a sanitary rooms. For the common sanitary rooms, these sanitary rooms are near to the mess rooms where many people are eating and they just want to wash their hands and go for the shower or urinals or WC. For these are called as the common sanitary rooms. And for common sanitary rooms, laundries, drying rooms, iron rooms, minimum 15 air changes per hour. Then you have changing room, janitor and cleaning lockers has to be exhaust airflow minimum 10 air changes per hour. Then you need to have the public sanitary rooms in passenger ships also 15 air changes or the rate which is already given in the table. So you need to clearly understand while calculating the exhaust airflow. This is very very important table. So you need to understand while calculating the values of the exhaust airflow. So just mug up this table carefully before going to interview which how many air changes for which areas. So this is going to certainly help you. Remember this is a part of ISO 7547. So take it very seriously, and this is being commonly and frequently asked in the interview. So you should know it very very perfectly. So mug it up properly. Now let's go to the next session. Now this particular slide is again the exhaust system. The section 6.4.2 exhaust system states that the exhaust system from the space listed below shall be directly fed to an open air and not used for the recirculation. Additionally, the exhaust air system for each of these spaces or group of the space shall be separate from each other. It says that suppose you are taking the exhaust from these spaces, it should be an independent exhaust. That means an exhaust fan should not be connected to any of these spaces except that those spaces. And what does it mean is I will just explain you. And one more thing is that none of the air which is supplied to these particular spaces should again come back to the recirculation. Uh, the hospital is medic room, sanitary room, laundry and pantry. These four spaces should have its own independent exhaust system, exhaust fans, one working, one standby. The reason is that because as you know, medic rooms, the contamination should not be there, so it should be negative pressurization. Then sanitary rooms, of course, the smell should not spread. The laundry, of course, because you have a lot of drying, then heating is getting generated. And again, the pantry, again, for the obvious reasons. So these are the spaces where you need to have an independent exhaust fan, and these are the spaces where the air you should not take it back. Whatever air conditioning air you're supplying into this room, everything 100% you need to exhaust. Let's go to the next point. It is section 6.5, air balance. The system shall be positively balanced. It should be applicable on every deck. It means that the positive pressurization should be the part of the system, and it is independent of this laundry and sanitary room and hospital where the negative pressurization you need to maintain. Then apart from these rooms, you need to get the positive pressurization in short. And the rooms where these when the in the rooms where there is a one tumbler or dryer, the balance between the supply and exhaust should be considered. Okay, so every tumbler dryer as a manufacturer, it has a different requirement for the airflow. So while designing your exhaust system, you need to consider that what is the requirement for the tumbler dryer for that particular while designing the laundry system over here. There will be catalog over there which tumbler dryer you are selecting. As per the catalog value you should select and match with the requirement of an exhaust fan, selection of exhaust fans. Then hospitals, galleys, food preparation areas, other rooms such as smoking rooms, etc. shall be maintained at slightly lower pressure than the adjoining spaces. Because as you know, food preparation, the smell comes out. The galley also, the kitchen, the smoke comes out. Or the smoking room, of course, the people smoke there for obvious reasons. So these are the spaces need not be positive pressurized. It should be slightly lesser pressure than the adjacent so that smoke or whatever smell or whatever it is, it should not travel from one area to another area. Rather it gets exhaust and the fresh air, it gets replenished by the fresh air. So these are few areas it has to be slightly negative pressure than respect to the other areas. So I think it's clear. Let's go to the next one. Let's come to the very important chapter, that is occupancy over here. Well, we'll be talking about the occupancy. Section 4.5 clearly defines what the occupancy we should take per room or per area. Uh, in most of the majority of the drawings, you may not find this occupancy, so you need to assume some kind of an occupancy for these areas. So when the drawing comes to you, of course, these thumb rules you can use, which is clearly stated in section 4.5 for the occupancy. For cabins, maximum number of persons for which the cabin is designed, that you can find from the number of beds which is kept on the or shown in the cabin. So you can easily find out the number of people. So suppose there's a bunk bed is there, of course you can say two people are for the cabin. For saloons, one person per 2 square meter of floor area. For mess or dining room, one person for 1.5 square meter of area. Then for recreation room, one person for 5 square meter of area. For captain or chief or engineer's day room, it's 4 person. And other private day rooms, you should consider 3 person. For hospital, medic room, it is number of person plus two, number of beds plus two people. For gymnasium or the games room, 4 person. And for first aid room, 2 people. For offices, 2 people. For machinery control room, 3 people. So this is what you can use for this section 4.5 for the occupancy of the areas. So let's go. Hope the topic is clear because air conditioning when you design, you need to decide the occupancy. So these are the areas, these are the rules. Section 4.5 you can use and you can apply that to the system. Now let's go to the next one. Here section 4.2, if you see, it talks about heat transmission and gain loss, and this is the formula which has been given over here, and this is what each one means. So let's see what it means over here. And when we talk about this section is 4.5, and obviously this formula talks over here about the heat transmission or heat gain or heat loss. So what is that? Let's go one by one. Is delta T is nothing but the difference in temperature in degree Kelvin, that is difference of air temperature between the air conditioned and non-air conditioned internal spaces. The kV here stands for the total heat transfer coefficient in watts per square meter per Kelvin for the surface area. Then let's go to AV. What is AV? AV is surface area in square meter excluding the side scuttle and rectangular windows, and glazing plus 200 mm is what the section 5.2 talks about it. Then let's talk about the kg. It is not a kilogram, but it's a total heat transfer coefficient in watts per square meter per Kelvin for the surface area AG. And what is AG again here? The surface area in square meter of side of the scuttle rectangular window, that is glazing by 200, is what is AG. So if you put all these values over here, you will get the heat transmission or heat gain loss for the windows. So anyway, let's go to the next one so you'll understand in better way the other factors also. Now here we are going to look at the temperature difference between the adjoining surface. Section 5.2.2, temperature difference between the adjoining thermal spaces for the difference of the temperature degree Kelvin between the air conditioned and non-air conditioned internal spaces. It's mentioned in table 1 of section 5.2.2. What does it mean? Suppose you have one room air conditioned and other room non-air conditioned. There's a partition between. So these are the guideline temperatures difference delta T which is given and which we have to use it while calculating the heat load calculation. So wherever the partition section or partition portion of the calculation is coming, you need to use these values. So let's go one by one these values. What are these values? One is the type of bulkhead. Bulkhead, as I explained earlier, bulkhead is nothing but a wall. It's a deck against tank provided with heating. Suppose your wall or bulkhead is against the tank with a heating, then for the summer you need to consider delta T of 43 and winter you need to consider 17. Similarly, for deck and bulkhead against the boiler room is mentioned over here. Then deck and bulkhead against the engine room and against the non-air conditioned gallery, you need to consider 18 degrees Celsius. Then again the bulkhead against the non-heated tank, cargo spaces and equivalent 13 degrees Celsius. Then deck and bulkhead against the laundry is 11. Deck and bulkhead against the various sanitary spaces is 6 degrees Celsius. And deck bulkhead against the sanitary spaces of exposed, non-exposed and other areas you need to consider respectively 2, 1, 6, and bulkhead against the galleyways, storeroom, equivalent spaces and equivalent trunks are considered 2 degrees Celsius. So this is what are the guidelines given. So just you need to mark it up properly before going to interview, and the temperature difference between the adjoining spaces is explained in this particular section 5.2.2. So these values are also being commonly asked in the interview. So you need to take a note of it. And always remember that these are the provision for ISO 7547. So you need to understand the standard very well for going to interview, and you can tell to the interviewer that this is what the standard we have used. Let's go to the next slide.